In this video, we're going to highlight the differences between a dehydration synthesis reaction and a hydrolysis reaction. So let's start with dehydration synthesis. So what does that word tell you, dehydration? Hydration has to be water. But dehydration involves the loss of water. Think of, let's say if you're jogging and it's hot outside, you're dehydrated, you lost a lot of water. So a dehydration synthesis reaction involves the loss of water. Now think of the word synthesis. You're synthesizing something or you're building something. So those are two characteristics of a dehydration synthesis reaction. Now if we think of the word hydrolysis, hydro means water, lysis means to split apart. So in this reaction, we are using water to split apart something. So let me give you a good example of a reaction. So let's say we have H plus some monomer A, and then it's going to have an OH group next to it. And then we're going to react that with B, which will have a hydrogen and a water molecule, or rather a hydroxyl group on it too. So when these two monomers react, they will combine, releasing water. So water is going to leave. So once we have the loss of a water molecule, the two monomers A and B will join up together. And so we're going to get a larger molecule. So we're synthesizing A and B into a bigger molecule, AB. Hydrolysis is the reverse. In hydrolysis, we're going to take a big molecule, such as the molecule AB, and we're going to break it up into two smaller parts. And we're going to use water to do it. So we're going to add water, and that's going to help us to split apart those two monomers. And so we're going to get what we started with. That is the two individual monomers A and B. So hydrolysis and dehydration synthesis, these two reactions are reverses of each other. They're the exact opposite processes of each other. In a dehydration synthesis reaction, you're taking small molecules and you're building them together to form a large molecule. In hydrolysis, you're taking a large molecule and you're using water to break it down into smaller molecules. So another example would be combining glucose and fructose, two monosaccharides, and turn it into a larger molecule called sucrose, which is a disaccharide. So that's an example of a dehydration synthesis reaction. The reverse would be hydrolysis. So if we take the disaccharide sucrose, and then if we add water to it, we can break it down into glucose and fructose. Now granted, you might need an acid catalyst to accelerate this reaction, but you'll need water in the net equation to break down sucrose into glucose and fructose. So glucose and fructose are monomers. When dealing with carbohydrates, they're known as monosaccharides. And when you take many small monomers to make it into a polymer, that's going to be a dehydration synthesis reaction. Another example is converting glucose into starch. Starch is a polymer made up of many glucose monomers. So that is a dehydration synthesis reaction. Now, when you take starch, add water, and break it down to glucose, that will be hydrolysis. Now, keep in mind, when synthesizing starch from glucose, water will be a byproduct, as in the case of all dehydration synthesis reactions. Now, another example would be taking many amino acids and synthesizing them to form a polypeptide chain, or even a protein with a specific 3D structure. So that's another example of a dehydration synthesis reaction. Or the reverse, if we take a protein, which is a polymer, And using water, we can break it down into many amino acid monomers. That will be an example of a hydrolysis reaction. So now you know the differences between these two reactions, the reverse processes of each other. So that's it for this video. Thanks again for watching.